A very good morning to all of you. In the last video of arithmetic progression, I have discussed words problem based on an arithmetic progression. Here in this video, I am going to discuss two different concepts. The first one as how to insert an arithmetic mean between two given numbers, and the second, properties of an arithmetic progression. But before I start, let me have a recap that what we mean by saying arithmetic mean. When three quantities are in arithmetic progression, the middle one is said to be arithmetic mean of the other two. That is already discussed. Now here, just try to understand, if A and B are any two given numbers and A1, A2 till AN are given in AP, then this capital A1, A2 till AN are n number of arithmetic means between A and B, where A is the first term and B is the last term. That is, in this case, total number of terms are n plus 2, because n arithmetic mean we have calculated and A is another term and B is the last term. So including all these, we are having total number of terms as n plus 2. Since last term here it is B, so using the formula of nth term of an AP, we can write B is equal to A plus n plus 2 minus 1 into D, which gives the common difference D equal to B minus A divided by n plus 1. That is last term minus first term whole divided by n plus 1, where n is the number of arithmetic mean required to be inserted between two given numbers A and B. So here we can find A1, that is the first number of arithmetic mean, as A plus B minus A divided by n plus 1. In the same way, the second arithmetic mean, that is second term for the arithmetic mean, it can be calculated A plus 2 into D, that is B minus A divided by n plus 1, as it is explained here. In the same way, the nth arithmetic mean can be calculated as A plus n into B minus A divided by n plus 1. It is very important to note here that sum of all n arithmetic means inserted between A and B is equal to n times the single arithmetic mean between A and B. That can also be written in symbolic form as sigma from r is equal to 1 till r is equal to n. It is equal to n into capital A, where capital A is the single arithmetic mean between A and B. To make this point more clear, I have considered one example for you here. Try to understand it. In this question, it is given that between two numbers whose sum is 13 by 6, an even number of arithmetic means is inserted. The sum of these means exceeds their number by unity. Find the number of means, that how many means are inserted between these two numbers. So let A and B be the two numbers and 2n arithmetic means are inserted between A and B. Then according to the given situation here, because here it is given that the sum of these means exceeds their number by unity, so using that concept we can write 2n divided by 2 into A plus B. A plus B by 2 is the arithmetic mean between A and B. It is equal to 2n plus 1, which after simplification we are already having the sum of first term and last term. It is given here in the question 13 by 6. So using that, here we have n into 13 by 6, it is equal to 2n plus 1, which gives n is equal to 6. Therefore number of means we have considered as how much? 2n. So it is equal to 12. 12 is the right answer. Now moving towards the next concept, that is properties of an arithmetic progression. One by one I am going to discuss all 6 properties. So please listen it carefully and make a proper note of it. The first one is, for any real number a and b, the sequence whose nth term is, nth term means general term, an, it is equal to an plus b, is always an AP with common difference a, that is coefficient of the term containing n, that is the common difference. Second property it is, if any nth term of a sequence is a linear expression in n, then the given sequence is an AP. Third property it is, if a constant term is added or subtracted from each term of an AP, then the resulting sequence is also an arithmetic progression with the same common difference. Fourth property it is, if each term of a given arithmetic progression is multiplied or divided by a non-zero constant, let us consider that constant as k, then the resulting sequence is also an arithmetic progression with common difference k into d in case of multiplication or d by k in case of division respectively, where d is the common difference of the given arithmetic progression. The fifth property it is, in a finite arithmetic progression, the sum of the terms equidistant from the beginning and end is always same and is equal to the sum of first and the last term. It is very important, so I am going to repeat it. In finite arithmetic progression, the sum of terms equidistant from the beginning and end is always same and is equal to the sum of first and the last term. And the last property it is, if three numbers a, b and c are given in AP, then using the concept of arithmetic mean we can write 2 into b, it is equal to, that is 2 into second term, twice the second term, it is equal to sum of the first term and the last term, that is a plus c. 2b is equal to a plus c. In order to make these all properties and the concept inbuilt in it more clear, I have considered few examples for you, and here is the first one. In this, if b plus c minus a by a, c plus a minus b by b and a plus b minus c by c are given in AP, then prove that 1 by a, 1 by b and 1 by c are also in AP. In order to solve it, in the question it is given that b plus a minus a by a, c plus a minus b by b, a plus b minus c by c. This is also already given in AP. So if I am going to add 2 in each term, this will again remain in AP, because I have already discussed here in the properties of arithmetic progression that if constant term is added, then the resulting sequence is also an AP. So same constant term 2 I am adding, so this will result in AP. Now after simplification, here we are left with, in the numerator, a plus b plus c by a, another term c plus a plus b by b, and third term it is a plus b plus c by c. That is, in all three terms the numerator is same, that is a plus b plus c. So on dividing each term by a plus b plus c, this given sequence will again remain in AP. But what we will get? We will get the result. Result is 1 by a, 1 by b and 1 by c. This proves that this is also in AP. Now let us consider another question. And here in this question it is given that if a1, a2 and so on till a7 are in AP such that the fourth term, that is a4, it is equal to 10, then find the sum of all the 7 terms of this AP. Since in finite arithmetic progression, the sum of terms equidistant from the beginning and end is always same and is equal to the sum of first and the last term, as I have discussed here in the properties. Thus we can say the first term and last term as a1 plus a7. This will be equal to second term plus sixth term, that is a2 plus a6. This will be equal to third term plus fifth term, that is a3 plus a5. This will be equal to a4 plus a4, and a4 it is already given equal to 10. So we can write a4 plus a4, it is equal to 20. Now, since we have already calculated the sum of first term and seventh term, in the same way second term and sixth term, third term and fifth term, and twice the fourth term. So we can write here using this relation a1 plus a2 plus a3 plus a4 plus a5 plus a6 plus a7, that is sum from first term till seventh term. This will be equal to 7 by 2 into a1 plus a7, that is first term plus last term, using the formula of sum of n terms. So it is 7 by 2 into 20, that gives us equal to 70. Thank you for today.